Titration. We have 4 parts: standard solution, rinsing equipment, titration, and equivalent point. We start off with titration. Titration. Titration is an acid and a base neutralizing. When acid and base neutralize, the H plus ion and the OH minus ions should be equal, and that's called neutralize. If we look onto the number of moles of acid molecule, this number of mole of acid molecule should balance to the number of moles of base molecule. Repeat, number of moles of acid molecule should balance to the number of mole of base molecule. And we're using this neutralization to do the calculation. And students will quickly realize that is two funny gadgets, the pipette and the burette. So do not get confused with the calculation. These two equipments only to help you to make the calculation more accurate. The principle is the same. Now let's look on to each pipette and then burette. Pipette normally is to hold the known volume and the known concentration. Remember, they carry a specific volume. Burette is to carry the known volume and unknown concentration on the sample that you're testing. And the volume will be variable, can adjust. Now let's talk pipette. I have 3 pipettes. I have the 2 ml, 5 ml, and the 10 ml. I'm choosing the middle 5 ml. So what is the difference of using pipette instead of using a test tube? Say here, 5 ml to 5.1 ml. That is the difference. Will be very little to see. But if I'm using the 5 ml pipette, 5 ml, 5.1 ml. So it gives you a clear indication, so you can calculate a specific volume. Now look onto the burette, which carry the sample of known volume and unknown concentration. Here, this one, the burette, you have an adjustable part that you can let out and then you can shut it off. And when you shut it off, you can calculate the volumes being dripping. So this also gives you a calculate volume. And now let's see a calculation. You have that much of HCl at that much concentration was completely neutralized with that much of NaOH. Calculate NaOH concentration. Equation, formula, we start. First, HCl. You know the C, you know the V, you know the mole. NaOH, you don't know the C, you know the V. Now, can we using this acid-base neutralization rule to find out the C of this sample NaOH? This is titration. Now let's see how do we find out. C times V give mole. when acid and base fully neutralize, number of acid must equal to the number of base. So, the number of mole of acid should equal to the number of mole of base. That is the important part. So, when they equal, you can find the N. Here, if you know the N, you can find the concentration of that sample. What is titration? Titration is using acid base. When they neutralize, you will know how many mole should equal to the same amount of mole. And you knowing these two relationships, and so you can find the unknown concentration of the sample. This is titration. Now let's see the experiment aspect. HCl, you know the concentration, you know the volume. Now you're going to put the full bottle in. Now you're going to put indicator. The indicator will change color when they fully neutralize. Then you put the NaOH in by dripping little bit by little bit. When the color change, you shut off the bottle, the stopper. Then this indicate at this stage the mole of acid equal to the mole of base. So now you knowing how much been dripped from the burette, so you know the volume, and by this relationship you can find the unknown sample of concentration. This is titration. Now, on the last example, we're talking about is a monopotic situation. When you have a monopotic acid neutralizing a base, they will release a H plus ion, and the base release one OH minus ion. So they're in one-to-one relationship. But be careful, when they have a dipotic will be different. Like on the middle picture, one acid, they require two base to fully neutralize. One acid requires two base to fully neutralize. And here on the following two examples, first is a monopotic, second will be a dipotic. Now let's start. Example 1. That much HCl monopotic with that much base. Find unknown NaOH. Equation. Formula. What's been known? You know the V, you know the C, so you know the mole. NaOH, you know the volume, but you don't know the C. You want to find the concentration of this C. That's the purpose. How? By titration, neutralizing. Here, the mole should be 0.09. When they fully neutralize, NaOH must be the same. So when NaOH the same, you can use this relationship to find the C. That's titration. Sample 2, dipotic. That much sulfuric acid, H2O, neutralize NaOH, find NaOH concentration. One acid requires 2 base. One acid requires 2 base. Equation, formula. Acid, you know the C, you know the V. Base, you want to find the unknown C. Here, C times V give mole. Careful, this relationship, should they be equal? No, it should be double times 2. You have to times 2. It is a diprotic, so it's 0.18 mole. Then you're using this relationship. You know the volume they given you, mole, so you can find the concentration. That is titration. Challenging question. What makes titration difficult? The reason titration difficult actually partly is because students don't remember the valency well and don't remember the acid and the base formula well. For example, magnesium hydroxide, I saw students who forgot that it's 2 because Mg2 plus, OH is 1 minus, and the balancing salt is MgCl2, and you need to have 2 acid to balance. Same as calcium hydroxide, students forgot to write the 2, and that's they have the wrong balancing, and you need 2 HCl, and calcium chloride is a 2. Sulfuric acid, diprotic. I find students still get wrong sometimes. So you need to have 2 base. Sodium sulfate. How to write sodium sulfate? Na is 1 plus, sulfate is 2 minus, so you need 2 sodium. Nitric acid. I find some students still don't know how to write nitric acid. This is nitric acid. So, and acetate, or called ethanoic acid. Students still struggling to write ethanoic acid. So please know what sort of salt they form. Sodium 1 plus, acetate 1 minus. So student reason they don't do well on titration is because they cannot do the equation properly. They don't know ethanoic acid, the formula, and what is the valency will be balance B. So this is the thing you should work on. Like sodium carbonate, Na2CO3. What sort, when it react with acid, what should it form? Always carbon dioxide and water. Acid with carbonate always form carbon dioxide and water. Acid with ammonia. Ammonia is a base. It forms ammonium, NH4. So student, the equation sounds straightforward enough, but I find students always make miscalculation because they don't remember the valency well, and this causing the problem. So please work on this so to help on your calculation.